In this video, we are going to discuss some problems on how are we going to find the eigenvalue and eigenfunction of a problem related to storm level problem. So in the question we have that find the eigenvalue and the corresponding eigenfunction of the storm level problem. You can see that this is a storm level problem. So we have to find the eigenvalue. So it means if we want to find the eigenvalue of this problem, that is a storm level problem, we have to consider three cases. First case is when lambda is equal to 0. Second case is when lambda is less than 0. Then third case is what? When lambda is greater than 0. This is what we are looking for. That is, when lambda is equal to 0, we will find what are we going to get. When lambda is less than 0, we consider the second case. While the third case is what? When this lambda is equal to what? Is greater than what? 0. So you can see that this is a storm level system. And as I explained in the previous lesson, our storm level system is the general form of storm level system. But how are we going to look for this lambda? So first thing is what? To find what? To consider case 1, that is when lambda is equal to 0. So before we talk when lambda is equal to 0, you can see that this one we have to what? This is a what? Homogeneous differential, second order homogeneous differential equation, whereby where we have ay double ay prime prime plus by prime plus cy is equal to 0. You can see that this one form a what? This one is you can see that is a order 2 second order homogeneous. So in this case, this one is a is 1, while by prime is what? We don't have it. We only have what? Y, which is c. So in this equation, we are going to assume that y is exponential ms. If you remember, y prime, we assume that a general form of e to the ms y prime, if we differentiate this one with respect to x, we are going to have m multiplied by everything, m exponential mx. Y double prime, we are going to have what? M square exponential ms. If we differentiate this one with respect to x, we are going to have 1. M times 1 m multiplied by everything, we have m square. So whenever we have y prime prime, we put this one to this. So what are we going to do next? We are going to consider this first. But for us to solve this, we're going to consider case 1. Case 1 means when lambda is equal to what? When lambda is equal to 0. That is when lambda is equal to 0. So solution to this, solution, we consider case 1. Case 1 when case 1 lambda is equal to what? 0. So it means whenever we see this sign, we put 0. So this is our storm level problem that we have been given. So y double prime plus lambda y is equal to 0. If your lambda is equal to 0 here, you are going to have y double prime plus lambda. Lambda is 0. 0 times y is 0. So lambda is equal to 0. So you can see, so I have differentiated what is our y prime prime. We assume that y prime prime is what? M square exponential ms. So it means whenever I say y double prime, I put what? M square exponential ms. So I'm going to have m square exponential ms is equal to 0. If I divide both sides by exponential ms, I'm going to have this one will cancel. 0 divided by anything, 0 divided by any number, I'm going to have what? I'm going to have 0. So I'm going to have m square is equal to what? 0. M square is equal to 0. So what are we going to do? So for us to get our m, I have to what? To square root of both sides. If I take the square root of both sides, I'm going to have m square is equal to 0 square. Then this will cancel. Whenever I take a square root, I'm going to have plus or minus. So I'm going to have m is equal to plus or minus 0. So our answer is m is equal to 0. So minus 0 is also known as what? 0. So whenever you can see that this form an auxiliary equation. It's form an auxiliary equation. So whenever we have anything m is equal to 0, is a repeated root. This is a repeated root. So whenever we have a repeated root, our general answer will be y of s is equal to a exponential ms plus bs exponential ms. But if you don't have a repeated root, suppose this one is 0, here is 1, I'm not going to have x here. But it's a repeated root, they are the same. That's why I'm going to have x here. So it means whenever I see m, I put 0. So I'm going to have a exponential 0x plus b exponential b s exponential 0x. So I'm going to have a plus bs. Anything raised to power 0 is 1. 1 times a, I'm going to have a. Anything raised to power 0 exponential, anything raised to power of 0 is 1. Exponential 0 is what? 1. S bs. So this is my answer. So my y of s is this. This is not the solution. So we have been given y of 0 is equal to y of n is equal to 0. This is the boundary problem, boundary condition. It means we are going to test when y of 0 is equal to what? Y of x is equal to 0. What are we going to get? It means whenever I say what I have here is x, that is ys is what? 0. So whenever I see x, I put what? I put 0. I'm going to have y of 0 is equal to a plus b. My s is what? 0. So what's my y of 0? Y of 0 is equal to what? Y of n. So I'm going to have y of n is equal to what? A. So where my y of n is equal to what? 0. So my y of n is equal to what? 0. So I can write as what? 0 is equal to a. Therefore, a is equal to 0. So what are we going to do next is to find b. So how are you going to find b? So for me to get b, let me use this equation. Y of x. So y of n is equal to what? Y of s is equal to what? A plus bs. Which means whenever I see x, I put what? N. So since I want to find y of n, so I'm going to have n here. I'm going to have n here as well. So my y of n is what? 0. I'm going to have 0 is equal to what? A plus bn. Remember that my a is 0 already. I'm going to have 0 here. So my answer is 0 is equal to what? Bn. I want to get b. What am I going to do? Divide both sides by b. If I divide both sides by b by n, I'm going to have what? 0 is equal to b. So therefore, my a is equal to 0. My a is 0 as well as what? My b is equal to 0. So this gives me a is equal to b is equal to 0. If I have a is equal to b is equal to 0, we call it a what? A trivial solution, because a is same thing as what? B. A is equal to 0. A is equal to b, then is equal to 0. That is, it is a what? A trivial solution. So my second step is to what? To consider case 2. Case 2, when lambda is what? When lambda is less than 0. If something is less than 0, it means it's not up to what? This lambda. So this shows that our lambda is negative. Means our lambda is negative. That is, this lambda is less than 0. That is, minus 1 is less than 0, minus 2 is less than 0. So it means this lambda take a negative value. So therefore, we have negative lambda. So it means whenever I see lambda, I'm going to put negative lambda. The sign is called lambda. So it means I'm going to have y double prime plus. So lambda is what? Negative minus lambda, then multiply by what? Y is equal to 0. So I'm going to have y double prime minus lambda y is equal to 0. So from here, I will assume that my y double prime is what? I've gotten the y double prime is what? M square exponential ms. Whenever I see y double prime, I put m square exponential ms minus lambda. What's now my y? My y is what? My y is given as exponential ms. Exponential ms. Then is equal to what? 0. So let me divide both sides by exponential ms. So I'm going to have, this is going to cancel. This one is going to cancel. 0 divided by exponential, I'm going to have 0. I'm going to have m squared minus lambda is equal to 0. So in this case, I can take my lambda side to the right hand side because I don't know what lambda is. I'm going to have m squared is equal to lambda. So what am I able to do? So to take the square root of both sides so I can get what m is. So I'm going to have square root of m squared then is equal to lambda plus or minus. So my answer will now be m is equal to plus or minus square root of lambda. So my answer is m is equal to plus or minus square root of lambda. So therefore I'm going to have my answer m is equal to plus or minus with lambda, which give you which m is equal to lambda, square root of lambda, or m is equal to minus with lambda or square root of lambda. So you can see that in this my m is not my m is equal to with lambda is different from this. This is what not repeated root. So whenever I have this, my general solution of this will be a exponential ms plus b exponential ms. So my m is what? With lambda. Whenever I see m, I put with lambda. A exponential with lambda x, then plus the b will take the negative, the b will take the second m, b exponential minus with lambda, then x. So I've solved this one. So this is my general solution for this. But we are being given a condition that is our y of 0 is equal to y of n is equal to 0. Whenever I'm going to test for this, whenever I see s, here is what? X is equal to 0, when s is equal to what? N. So I'm going to y of what? Y of s is y of 0 is equal to a exponential with lambda. My s is what? 0 plus b exponential minus square root of lambda, then 0. So here I'm going to have y of 0 already is what? Y of n. So I'm going to have y of n is equal to a. If I multiply this with lambda times 0, I'm going to have exponential 0 plus b exponential negative with lambda times 0, I'm going to have 0. So finally my answer will be a exponential 0 plus b exponential 0. That is anything over 0 is 1. So my answer will now be a plus b is equal to what? Y of n, I'm going to y of n is equal to a plus b, a plus b. Remember that my y of n is already 0. So I'm going to have 0 is equal to what? A plus b. So my a here, therefore my a here should be what? Minus b. I take b to the what? To the left hand side, that is to the 0. So a is equal to minus b. So let me test for y of n. So it means when I have y of s, I'm going to have y of n is equal to what? A exponential with lambda. Whenever I see s, I put n plus b exponential minus with lambda, then n. So in this one, y of n is already 0. So my a is what? Minus b already. So I'm going to have b square root of lambda n plus b exponential minus with lambda n. So in this case, you can see that minus b exponential with lambda n plus b exponential, they are the same thing. So it's going to what? It's going to be what? Nothing. So therefore, my a is equal to 0 and my b is equal to what? 0. So my a is equal to b is equal to 0. You can see this is a trivial solution. Trivial solution. So the next one is what? To test for my what? My third case, that is when lambda is greater than 0. What am I going to have? So let us go to it. So my case 3 is when lambda is greater than 0. When lambda is greater than 0. So number greater than 0. If lambda is 1, 1 is greater than 0. 2 is greater than 0. So it means positive number is greater than 0. So yeah, I'm going to have my lambda will be what? My lambda, therefore my lambda will be what? My lambda is positive. So it means my lambda is what? Plus lambda. My lambda is what? Plus lambda. So it means whenever I see, I will go to my Stonehill problem that I was given already. I'm going to substitute plus lambda to what? When I see lambda. So it means positive. So y double prime plus what? Lambda y is equal to 0. This is what? This is my Stonehill problem. So when lambda is what? Plus lambda, I'm going to have the same thing. So y double prime, because of my time, I know that y double prime will give me m square plus, so my lambda is what? Lambda, but my y is what? 1. Because if I take the exponential, I'm going to exponential will cancel exponential, I'm going to have 1. So it's equal to 0. So I'm going to have m square plus lambda is equal to 0. So for me, what are we going to do here is to take plus lambda to 0. So I'm going to have m square minus lambda. So if I take the square root of m, if I take the square root of both sides, I'm going to have minus with lambda. This will cancel this will plus or minus. I'm going to have m is equal to plus or minus what? Minus lambda. So I can write this as this n plus minus lambda. So this is plus or minus. So minus lambda, I can write this one as minus root lambda. Remember that when I have anything, if I have square root of minus 4, so minus 4 is what? Too high. Because this one is going to turn to what? Real part and imaginary part. So I don't know what minus lambda is. So I'm going to have minus lambda already. But I want to make that negative. It means I'm going to have lambda I. So it shows that negative have turned to what? I. So I'm going to have lambda I. What am I going to do here? It means my n is equal to what? 0 plus root lambda I, or n is equal to 0 minus root lambda I. So whenever I have a conjugate root, it means my general solution will be, I'm going to have exponential alpha s, then a cos beta s plus d sine beta s, where my alpha is the imaginary part, where my beta is what? Imaginary part. So what's my real part here? My real part is 0. Since whenever I say alpha, I put 0. My alpha is 0, then my beta here is what? With lambda I. So if I substitute it to here, I'm going to have y of s is equal to exponential 0x alpha is turned to 0. Then I'm going to have a cos beta. My beta is root lambda is. So I'm not going to have I again. Remember that whenever I have anything related to this, I'm not going to have y. I'm going to have the coefficient of what? Imaginary part, which is this. So I'm not going to have what? I anymore. Because of what? Because I must only take the coefficient of what? With lambda. That is the coefficient of what? The coefficient of imaginary symbol, which is what? I. So I'm now going to have a cos lambda, then followed by x, plus what? B sine lambda followed by s. So I'm going to have y of s. Anything else to power 0 is 1. Then I'm going to have a cos with lambda x plus b sine with lambda x. So it's only root that's affecting, that root solely affecting lambda, not x, lambda then x. So I'm going to test my boundary condition. Have you given y of 0 is equal to y of n is equal to 0? So let me test y of 0. I'm going to have y of 0 is equal to 1 a cos lambda then s. Whenever I say s, I put 0 plus b sine lambda then 0. So here with anything cos 0 is what? 1. So I'm going to have a, y of 0 is what? My y of n then is equal to what? A plus b sine 0. So anything sine 0 is 0. Y of n is equal to what? A. That is, my y of n already is what? 0. I'm going to have 0 is equal to a. Therefore, a is equal to 0. Then I've gotten my a, so I have to get my b. So I'm just substitute this into this. I'm going to have y of, so for me to get y of n, whenever I see s, I put n to test from the second boundary plus 1. Then I have 1. 1 is a number, so 1 multiplied this, I'm going to have this. Then a cos square root of lambda with lambda l plus b sine square root of lambda then l. It means when here is what? X. I have to test s is equal to 0. Then I have to test when s is equal to what? L. So when y of l is what? 0, I'm going to have a cos. We have a as 0. So I'm going to have a is 0 already. 0 plus b sine with lambda l. So from here, I can divide both sides by sine lambda l. If I divide both sides by lambda l, I'm going to have sine lambda l, sine root lambda l. Here also what? Sine root lambda l. To get my b, here will be 0. Here will be 0. So my b will be 0 as well. You can see that here, a is equal to 0, b is equal to 0. My case 1 is a trivial solution. That is, a is equal to 0, b is equal to 0. My case 2 is a trivial solution. A is equal to 0, b is equal to 0. So what I'm going to do is what? My case 3 must not be what? My case 3 must not be 0 as well. My case 3 should not be 0. How can I prevent it to not be 0? It means I'm not going to what? So what I want to do here is what? My y of l is 0 already. So that is my here is 0, 0 plus b sine root n. So I'm going to have b sine square root of n is equal to 0. And my b, I don't want b to be 0. If I don't want b to be if I don't want b to be 0, what am I going to take? What to take the coefficient of b, that is sine square root of pi only. I'm not going to consider this n. Why? My n is I'm not going to consider this n. I'm only going to take sine pi, the coefficient of what? Only sine here. That is my sine root will give me my sine n pi. This is another way we generate this one. Sine n pi means our n is greater than or equal to what? 0. If our n is equal to, if I put 0 here, sine n pi is 0. Sine n pi is equal to 0. If I put 0 here, when n is 0 here, so 0 times pi is what? 180. That is what? Sine 0 is 0. If my n is 1, sine 180 is what? 0. So that is my n is 1, 0, 1, 2, 3, 4 to infinity. Because I want to make what? I don't want to make b is equal to 0. So I have to add n. L is part of the sine pi n. Sorry, sine pi n is there. So you can see that I don't want to make b is not equal to 0. So what am I going to do is what? To take the coefficient of b, the value that is multiplying b sine root lambda n is equal to what? Sine n pi, where our n sine n pi is 0. So for us to confirm that sine n pi is 0, I don't want to make b as 0, because if I make b as 0, everything will be what? Trivial solution, and I will not get a solution for the value. So what am I going to do next is what? I told that where n is what? Where n is greater than or equal to 0, that is my n is 0, 1, 2, 3. Going. If I test this, when n is 0, if I put sine root n is equal to what? Sine n pi. When n is 0 here, here, it will be what? Sine 0 times pi. Pi is 180. That is what? Sine 0. When n is 2 here, sine 360. 2 times 180, that is 360. I'm going to have what? Sine 360 is what? 0. When n is 3, 3 times 180. So it means I'm going to have what? 0. This shows that what? For a whole number of n, sine is what? Sine is 0. That is my sine pi l is what? 0. What I'm going to do is what? To take out lambda from this. So this is what we have a value in left hand side, we have a value in right hand side. How can I remove only lambda here and we have square root of lambda here, so we can get my what? Eigenvalue. What am I going to do is what? To divide both sides by what? Sine. So if I divide both sides by sine, so I don't need to write this. I'm going to have sine lambda n is equal to what? Sine n pi all over what? Sine. All over what? Sine. If I cut this, I'm going to have with lambda n is equal to what? Sine will cut, I'm going to have n pi. I want to get the value for lambda, only lambda. So what is associated with lambda? N. I can divide both sides by n as well. N will cancel. I'm going to have lambda, square root of lambda, then n pi of what? N. And I want to get a value for lambda. So how can I remove that square root? To take what? To take square of both sides. If I take square of both sides, I'm going to have lambda square is equal to what? N pi all over n square. So this is going to cancel this. I'm going to have lambda is equal to what? N pi all over n square. This gives me that my lambda is what? N square pi square all over n. Therefore, my eigenvalue is n square pi square all over n. That is my solution. You can see that I've solved this solution. That is my eigenvalue is n square pi square all over what? N square. So my next is what? To find the what? Corresponding eigenfunction. How am I going to find corresponding eigenfunction? I will go to where I see lambda for my y of s for my general solution, which is what? B sine what? So for eigenfunction, I have my y of x I'm not going to consider this. I'm going to consider only base sign with lambda n. So whenever I see with lambda n, I put what? I put n square pi square over n square. So I'm going to use this base sign with lambda x. So I'm going to have base sign with lambda x. So whenever I see with, so what do I have here? And where lambda, where lambda is what? What's our lambda? Our lambda is what? N square pi square s square. So for me to get my with lambda, I'll just take the square root of. So for me to get with lambda as this, I'm going to have n square pi square all over what? L square. So it means the square root of everything will give me what? N pi all over L. So my eigenfunction will now be b sine, what is my with lambda? My with lambda will now be n pi of nx. Is my, so my eigenfunction is b sine n pi over nx. That is my eigenfunction. So my y of x now be my y of x, my y of n, y of n. So my y of n will now be what? Is y of n. That is my eigenfunction. This is my what? Eigenfunction. Eigenfunction. So therefore, my eigenvalue is n square pi square all over n square. Where my eigenfunction is what? B sine n pi all over n x. N pi over nx, and I explain how we got it. What we need is what? What we need is this base sign with pi of n, that from the general solution. I just take it here. So I've gotten my eigenvalue already. So and I have square root of what? Eigenvalue. My eigenvalue. So I have to take the square root of this. And if I take the square root of it, I'm going to have n pi all over n. So that's why I have n pi over n. So my y of n will not be b sine n pi over n multiplied by what? X. So that is the solution to this problem. I hope you find it interesting. Thanks for watching.